Okay, in this video, we're going to run through some hypothesis tests very clearly, and hopefully you'll get a good idea of them, one of each type. But before then, I need to talk about two different methods of doing the comparison part as to decide whether you're going to go with H0 or H1. So the two methods are critical region and p-value. Now, I'm going to be completely honest, p-value is the easier one. It's shorter, it requires less work. But the critical region you may be asked to do. If you are not asked to, you don't have to do it, but you do need to know how to do it because you could get asked. The critical region is the one that we've done up to this point, and that is working out which values are sufficiently weird, and i.e. which values would we have to observe to be in the alternate hypothesis situation. So I'm going to do it for this one. I already did this kind of in the last video, so it's the same example as before. Note that I am going to do the kind of easier, less than alternative hypothesis. And this is how I do it. So on my calculator on the right-hand side, you can see I've already filled in for the correct values. So I've got my values there, and I put 18 at 0.4, and it's calculated those values. And I can see that the point it switches from less to greater than 5% is between 3 and 4. So this is the test part of the hypothesis test, not the setup and not the conclusion. I would write that the probability of x being less than or equal to 3 is equal to 0.0327, which is less than 5%. I'm using 5% here. And the probability of x is less than or equal to 4 is equal to, I keep making this mistake because of that extra digit, that's 8. Less than or equal to 4 is 942. 0.0942, which is greater than 5%. Critical region is therefore x is less than or equal to 3, the bottom 5% of results. And so, since if we observed 2, we could say 2 is less than or equal to 3, and so we are going to reject H0 because it is in the critical region. You would conclude that there is enough evidence to suggest that p is less than 0.4. Now the p-value, all that says is just look at whatever the observed value is and decide whether it means it's in the bottom 5%. So all you have to do is you have to calculate that p of x is less than or equal to 2, which is the observed result. So this is the observed. And and if you're on your calculator, you could either, if you had the list up, you could either just go directly to it on here, or you could just work it out on the variable screen. I'm going to do that. So you would go into here, you'd go to binomial CD, just variable 2, and you'd calculate less than 2, so 2 for n is 18 and p is 0.4, and you would just get that result, which is 0.0082. And this is certainly less than 5%, which means you must be in the bottom 5% of results. The comparison is that, as I just did, I'm going to repeat it, that is less than this, and so we reject H0. And that's it. So that is easier. So to show you on GeoGebra, if I was doing, I'd find the critical region. I would be looking for when this result down here is less than 5%. That's there. The critical region is therefore 0, 1, 2, and 3. I observe 2, which is in the critical region. That's the critical region method. If I'm doing the p-value, I'm just going to see what less than or equal to 2 is. I can see that that is 0.008, which is less than 1%, which is less than 5%, and therefore I'm in the critical region, and that's it. you reject H0. So those are the two methods. So now we're going to move on to doing a hypothesis testing. And I'm going to initially show you both of these methods. So I'm going to go to an example here. It's quite a lot of words, and it takes a little bit of kind of getting used to how we're going to do this kind of question. You will notice here that this old spec exam question had 8 marks. It's probably slightly less in now because you have calculators that do a bit more. So I recommend you pausing it and just having a read of the question. Okay, I'm going to continue. There's a couple of things to spot here, and it's always a good idea to write down the key information from the question. So some key information, I can see this 5%, I can see this 10% over here, I can see 60 here, and I can see 1 bag there. So I'm going to start off by setting up the thing. I'm going to say let X be the number of faulty bags. Of blood. And I can see that X has a binomial distribution of 60, comma P, where we're going to be testing whether that P is 5% or not. Now, I know we've been using 5% for the significance level a lot, but we're just actually, that is the P value here. We're going to set up our hypothesis. This is all part of the setup. H0 is that P is equal to 5%, so that's 0.05. It's 5% because that is what we think the probability is. That's this 5%. And H1 is that P is, and this is where we have to stop and say, are we doing a less than? Are we doing a greater than? Or are we doing a not equal to? And I recommend you try and look in the question, what is it that makes us think which one we're going to use? That's the key word. It's reduce. It's reduce the proportion. So we have got to reduce the proportion. That's what we're testing for. So the answer is that what we're testing is whether P has reduced, is less than 0.05. It's a Lowertailed test. This is a Lowertailed test. Now we need to say what P is, where P is the proportion of faulty bags in the population. We often say in the population. It just means that, like, in all situations. So we're using the evidence of this particular situation to tell us about what happens in general. And that's the setup. So if you remember, I did the initial bit. That's my setup. I'm going to come back in a bit and talk about what words help you decide whether it's greater than, less than, or not equal to. I'm going to come back to that in a second. I'm now going to move on to the test part. So I need to find the critical region for this test, or I need to do the p-value method. I'm going to do both. So I'm going to start with the critical region method. The critical region method, you don't have to do both of these, and in this question, it doesn't matter which one you do, but it sometimes does ask you. So the critical region, we're looking for the 10% level. So I'm going to go to my calculator and I'm going to start setting it up. Now, one of the things you may notice is that I have got n is 60 here. N is 60 here. I'm not going to bother typing it all in. I'm only going to be doing it at the bottom end. I might just put a few numbers in because this at the bottom end. Also, the probability is very, very low, so it's likely to be a fairly small number. We're only testing one bag. So I'm going to put 60 and P is 0.05 and see what I get. I can see the numbers are already quite big here. We're already at 60% by 3. So what do we get? Well, I have got that the probability of x is less than or equal to, where does it switch between less than and greater than 10%, the significance level that we've been given in the question. 10% is between 0 and 1. So actually, 0 is 0.046. That is less than 10%. And the probability of x is less than or equal to 1 is equal to 0.1915. That is 19%. And that is greater than 10%. Therefore, critical region is x is less than or equal to 0, or actually you can just say x is 0. So the only result that we could observe that would make us think that the probability is less than 5% now is if 0 happened. Now, the observed is x is equal to, what is it? Let's have a look in the question. So what was observed? One bag. One bag is observed. So the observed is x is equal to 1. 1 is greater than 0. So we are not in the critical region of this test. We are not in the critical region of this test. We are going to accept H0. It is not weird enough. So we're going to go with accept H0, and then I would conclude. But I'm actually just going to do the p-value method as well. I'm going to do that now. I'm going to do the p-value method, just to show you that. So you don't have to do both of these, but this is what would happen in the p-value method. So all I would do is I would just calculate the probability of x being less than or equal to the observed result, which was 1. And that is 0.1915, which is greater than 10%. So we accept H0. And that's all you'd have to do if you're doing the p-value method, because it is greater than 10%. The observed value is that. Might say observed is x is equal to 1. Must do less than or equal to here, and that's it. So that is, and your choice of these two, this is the test part. Ooh. This is the test. And finally, we need to conclude. So here is my conclusion of this test. There is not sufficient evidence. You must always write it like this. There is or isn't sufficient evidence, is what you'd say. There is not sufficient evidence to suggest non-assertive language, as I said before, that now in context, the number of faulty bags has reduced. We have not gone with H1, we are sticking with H0. So again, just to double check, my conclusion, it is non-assertive. Because I said not to suggest, I said not sufficient evidence to suggest, and it is in context, because I talk about the faulty bags. Think about your conclusion as making sense to anyone. You shouldn't need to know any statistics to understand your conclusion. And here's the conclusion. I've already wrote that. And that is a hypothesis test for less than or equal to. Okay, what about the words that make us decide whether it's going to be less than, greater than, or not equal to? Well, I've got some key words up here on the screen to help you. So here are some keywords that you might see if you are trying to decide which option it is. So if it ends up being a less than or equal to, you could see has decreased, or is now less, or is lower than. So you're looking for lower than. If it's a greater than, you might see has increased, is now more, or is higher than. And a couple of tricky ones here. Overestimated. So if something has been overestimated, then it's actually lower. So that's why we end up with a less than. And if something has been underestimated, well, then it's actually higher. So it is greater than. Those appear initially the wrong way around. Not equal to, you're looking for things like has changed, or is different, or not the same. So you're just looking for something's different, something's changed. So those are the keywords that you should be looking for if you're doing those, if you're getting those kinds of situations. So these are the kind of things that you can look out for when you're looking at these questions and trying to decide which hypothesis test you're going to do. Okay, now I'm going to do this example. I'm going to use the p-value method on this. I'm not even going to do the critical region method because we've done a couple of those. So firstly, I start to read it and I start to look over it. You should do the same. I'm going to start writing out my thing. I'm going to start writing out what we did. I'm going to say let x be the number of tomatoes with a diameter over 4 centimeters. Now you'll notice that actually the 4 centimeters part of this question, it kind of is an annoying number in the question that we don't actually need. It doesn't make any difference to the hypothesis testing that we'll do. It's purely there. It's like, is the tomato bigger than 4 or smaller than 4? That's a yes or no. That's a binomial situation. Yes, no, bigger than, less than. So in a sense, I have written it down here, but I think we kind of need to ignore that. I think the 4 centimeter just kind of like puts you off. So we're not going to think about that too much. What we've got is we've got a binomial distribution, and the binomial distribution has an n of 40p. And I can see that that is my n. I can see I've got an observed result of 18. And I can see that the probability is 0.3. So when I'm constructing my hypotheses, I'm going to say that H0 is that P is either equal to 0.3, or I'm going to say that H1, P is something 0.3. While I'm writing down what P is, have a look, decide what you think it is going to be, less than, greater than, not equal to. There is a hint on the screen. So P is the probability of a tomato having a diameter over 4 centimeters. Okay, so what was it? What tells us what the change is? Well, it has increased. So we're going to go with greater than 0.3. Greater than 0.3. So let's have a look. What's the next part of the test? We've set it up. Now we're going to do the actual test. So I'm just doing a p-value. So I'm using the p-value method. It's going to be in the upper tail, and we have an observed of 18. So I want to find what is the probability of x being greater than, because it's an upper tail, greater than or equal to 18. And I want to compare it to, in the question, 5%. So is that going to be greater than 5%? So I can't do that. I have to do 1 minus the probability of something less than. The calculator only does less than or equal to. Now, what's it going to be less than? I just do my quick number line, 17, 18, 19. I want greater than or equal to 18, so it's 1 minus less than or equal to 17. So in my calculator, I go to Menu, Distribution, Binomial CD. I just want to do 1. My n is 40. No, that's going to be 18. No, actually, I want 17, don't I? Less than or equal to 17. My n is 40, and my p is 0.3. And I say that I get that value. So I'm going to write that down. This is equal to 1 minus 0.9680. And I can, if I want to check my value, I can store this as A. I can go here and do 1 minus my value of A. And I get that that is 0.0320. And the crucial thing is that this value, 0.0320, is less than the significance level of 5%. We are in the critical region. We are in the critical region. I'm just going to quickly show you that on a graph here. We've got n is 40. We've got p is 0.3. We are doing a greater than, and I can see that my answer of 18, this is in the top 5% because this is less than 5%. So we are going to reject H0. We are in the alternate hypothesis situation. So now it's time to conclude. So we're going to say there is sufficient evidence, because we are going to go with H1, there is sufficient evidence to suggest that, and now this is where I always stop and just have a look at the context, because I've kind of forgotten. I know it's about tomatoes. What's the context? We are testing that the fertilizer has increased the probability of having a greater. So we are saying, yes, that is true. There is evidence to suggest that the new fertilizer has increased the probability of a tomato having over 4 centimeter diameter. Okay, and that is that hypothesis test complete. Okay, I actually think I will make one more video on the two-tailed tests. I just paused there for a second and came back. I think now you've got to have a go at some of these hypothesis tests on the one-tailed tests. Exercise 7C. I put a few questions there on the screen, 2, 3, 7, 9, and 10. I think it's really important that you take a bit of time and really fully understand those. There will be another video coming where I will cover two-tailed tests. Hopefully it will be a slightly shorter video, and that will be the end of this chapter. Okay, thank you.